Hello, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. Today, I'm coming to you with scatter plots and lines of the fit. Thanks for joining me. First, let's look at what we mean by a positive correlation. It's a cat in the background, so don't mind us. As the x values increase is what we're looking at here. As we move from left to right, x values increase. There's an E on the end. Holy cow. The y values also increase. So if we were to draw a line of best fit here, oh, cat's on the desk, so sorry. The line of best fit would be what would go through kind of the center of this clump of points. I think it would connect this point and this point. So I'm going to try. You do better than me, but I'm going to try and make that happen. Oh, yeah, was not very good. But that's what our line of best fit would look like. Positive correlation also means positive slope. So let's choose the values of this point and this point, and we're going to find the equation of the line that goes through our line of best fit here. The coordinates of those 2 points are 502 and 4016. Now that we know that, we can find the slope. If we label these x1, y1, and x2, y2, we can say that 16 minus 2 over 4,000 minus 500 is the slope. Well, 16 minus 2 is 14. 4,000 minus 500 is 3,500. And in this case, it's such a big number, I want you to give me a decimal. So here, our decimal is 0.004 for our slope. Now, let's pick one of these points. I'm going to pick this first one, and we're going to use the point slope form. So not this one. We're going to eventually put it in slope intercept form. You know what? Let's get rid of my squiggles there. So we can use it in a little bit. For first, though, we're going to use the point slope form. Y minus y1 equals m times x minus x1. And we're just going to use x1 and y1 that we already have. So that's going to be y minus 2 equals 0.004 times x minus 500. Well, we do a little distributing. Y minus 2 equals 0.004 x minus, oh, now I need a calculator. 0.004 times 500. And that equals 2. Now we want to get y alone, so we add 2 to each side. We get y equals 0.004x plus 0. So we don't even really need this. And our equation for our line is y equals 0.004x. That's the equation for our line of best fit that goes through our scatter plot here. I didn't really say this a moment ago. A scatter plot is a whole bunch of data that you have, and you plot all of the values. If you're doing research, this is the kind of plot that you would get, because when you do a study, your lines, your data are not all going to fit in an exact perfect straight line, or they shouldn't. So you'll get this kind of smattering, this scattering of points. So we draw the line of best fit to best represent most of our data. So let's look at what a negative correlation would be. As the x values increase, I spelled that real wrong. I'm sorry about that. Oh, gosh. Oh, Lordy. As x values increase, the y values decrease. This is also going to mean a negative slope. So if we choose these two outside points, then we can connect those. Oh man, my line is awful. Let me try that again. There we go. Not too bad. My cats are nuts. So this is what the line of best fit would look like for this negative correlation. Now we need to find the slope of this line. Excuse me. So we can find the equation for the line. Our points are 20, 14. When x is 20, y is 14. And let's see, what is that? 122. All right, and we can label these x1, y1, x2, y2, and find the slope. So we have 2 minus 14 over 120 minus 20. It's going to simplify. 2 minus 14 is negative 12 over 100. Again, I want a decimal here, so let's negative 0.12 for our slope. Now, again, we're going to want to use the point slope form that we used above. So it's going to be y minus y1 equals m times x minus x1. When we pick one of these points, we can just choose the first point again. Y minus 14 equals negative 0.12 times x minus 20. Distribute a bit. Y minus 14 equals negative 0.12x. I need my calculator again. 0.12 times 20. That's plus 2.4. That's a 4. We add 14 to each side. We get y equals negative 0.12x plus 16.4. So that means our y-intercept is 16.4, which looks about right. We seem to be crossing the y-axis above the 16, and our slope's negative 0.12, which is what we got. Lastly, here we have the no correlation option that says as x values increase, the y values in both increase and decrease. There is no rhyme or reason to what they do. So when we have to find an equation for these lines of fit, they really don't have one. But I pick the 2 points in the center, like these two guys here, and that will be our line of fit. So we've got 4 points on top of our line above and 5 points below. So that's pretty good. Let's find the slope of this line. So we need some coordinate points. We can use 18, 58, and 39, 58. I already know them. That's why they're kind of weird points in the middle of everything, aren't they? Let's label x1, y1, x2, y2. So our slope is 58 minus 58 over 39 minus 18. So that is 0 over 21. 0 over anything is 0. So we want to know the equation of our line. So let's use the point slope form. Looks like that. We've got y minus 58 equals 0 times x minus 18. Well, we distribute, we get y minus 58 equals 0 and everything. 0 times anything is 0, so all we have left is 0. All we need to do here is add 58 to each side, and we've got y equals 58. That's the equation of our line of best fit. This is just a horizontal line at y equals 58. All right, so that's positive, negative, and no correlation. Let's flip it over and see if we can do a little bit of damage ourselves on plotting these scatter plots. All right, given the table of values, create a scatter plot from the data, then calculate the line of best fit and use the equation to make inferences. So we need to make that happen. So our X value is going to be minutes studying. If you have time as an option for a variable, it is going to always be your X value. And we have minutes here, so that's going to be X. And our test grade will be Y. Let's label our lines here. We've got everything jumps by 5s and 10s. 10's our lowest value, and it looks like 60 is the highest. So let's make every line 10. So I'm just going to label every other. So 20, 40, 60, 80, and then 100 will be here at the end. Our test grades, looks like the low test grade is 50 and the high is 95. So let's make our Y values the same. Every other line will be 20, 20, 40, 60, 80, and 100. Now, we need to plot our points. All right, so when X is 10, Y is 65. When X is 40, Y is 90. If you are bad at plotting points on a coordinate grid, this is the activity for you. 25, 70, right there. Let's get rid of that little guy. 50, 85. 15, 50. 40, 95. 25, 75. 60, 95. And 30, 70. So that's our coordinate points. Let's get a line of best fit going here. I'm going to say we should use, our lowest point here. Well, not lowest, but lowest X value. That's this one here at 5. Nope, that's not it. That's 1065. So we'll use that one. And let's use the, oh, sorry, that's my cat on the desk making life hard. Come on. Then we'll use this furthest one out here. And that looks like it's at 60, 95. So this point here, we're going to use those 2 points to find the equation of our line and make some inferences. So I'm going to scoop those up, but you remember them. Oh, one thing I meant to do. Let's label, oh, good Lord. Let's label our axes so we don't get confused. This is minutes studying. Got all my tools everywhere because of the cats. And then on the y-axis, it's the grade. All right, now we can do it. So we're going to use those points, 10, 65, and 60, 95. I'm going to write those down real quick. We're going to use those 2 points to find the slope. So the slope is, if we label those x1, y1, x2, y2, we've got, let's scoot this down a bit. Slope is 95 minus 65 over 60 minus 10. Well, that's 30 over 50, which is 0.6 for our slope. So this is a positive correlation because we have a positive slope. Our line of best fit, which I didn't draw, let's go do that, is going to have a positive slope. So we need to connect these 2 points. Our line of best fit looks something like that. Now that we know the slope, we can pick one of our points and use the point slope form to find the equation of the line. So we have y minus 65 equals 0.6 times x minus 10. Now let's distribute a bit. We have y minus 65 equals 0.6x minus 6. We're going to add 65 to each side. And we have y equals 0.6x plus 59. It's going to be the equation of our line. And we're going to need that to come down here below and make some inferences. Based on the data, which grade would be likely if a student studied for 35 minutes? Well, 35 minutes is an x value. All we need to do is take our equation, 0.6x plus 59, and plug in 35 for x. So we have y equals 0.6 times 35 plus 59. That means y equals, get my calculator here, 0.6 times 35 is 21. So that's 21 plus 59. That means y equals 80. That means we can assume if they studied for 35 minutes that they get a test score of 80. Let's do another one. Based on the data, how long would a student have to study to get 100? That means we're going to plug in, since grades are the y value, we're going to plug in 100 for y. So we have 100 equals 0.6x plus 59. We need to subtract 59 from each side. We get 41 equals 0.6x. Divide both sides by 0.6. Calculator. And that is 68.3. So to get 100%, you need to study about 68.3 minutes. I hope all this makes sense to you. I hope it's real clear. I hope you reach out if you have any problems. We're all together today, unless you're at home all the time. And if so, we miss you. I hope to see you soon.